I'm Jordan Ross. I'm an FOE with us. I've been here about 2 years, and I've been on the UAB Visual Arts project. It's in downtown Birmingham, kind of between the Al Stevens Center and the Old Highlands Hospital, on UAB's campus, obviously. Today I'm going to be just introducing the project. I think a lot of people in our company not really familiar with this project. I know Rob had commented on it at our summit a couple summers ago, but that's really the only thing I've heard about it. So I'm going to introduce the project. I'm going to talk about how we modeled it, how we use the BIM model, lessons we learned from using the BIM model, and ways ways we're working to become better there. And then I'm also going to touch on PLANGRID. I know Trey Darnell's introduced PLANGRID, and it's very effective even on a smaller project like ours, how we use it. So, like I said, most are not familiar with our project, but it is a kind of spaceship-looking contraption on UAB's campus that's coated in zinc metal panels. As you can see, this is a pretty current picture. Lots of interesting geometries going on. Up top, you've got a light monitor. You'll hear me refer to that a couple times. You've got a wing canopy. You've got an elevator enclosure. There's a we call it the football stair back here. There's not a lot of right angles on this building. And you couple that with a very, very tight site. There's not a lot of room to get around. It's a unique challenge. And so just a little overview. It's 26,000 square feet. Like I said, you can see up here you've got zinc metal panels that are coated the second floor. They're flat lock. They're actually pretty interesting. Like I said, I like the way this corner looks, how they give a really tight seam. But in addition to that, you've got brick on the bottom level. You've got curtain wall on the front lobby. You've got plastic glazing. There's lots of different material interfaces, lots of challenging geometries. And then you've got the project's bid a design bridge build, where a bridging architect, in this case Randall Stout out in California, designed a set of bridging documents. Us, with our design partner, Davis Architects and their consultants, hard bid the job, won the job, had 150 design days to get to construction documents, and then commence construction after that. And like I said, the program, the first floor is designed as a museum and art gallery space. So you've got some interesting finishes there. And the second floor, UAB will use more as classroom space for their arts department, and then the faculty offices that are associated with that. So some further details. And you've got the main lobby up here. You've got 21 foot ceilings in the lobby. There was not much ceiling space to begin with from design here, so no duct work. You've got perimeter heating trenches and a side diffuser. You've got the galleries are these three rooms right here. You've got 14-foot ceilings in those. You've got a large floor opening, so light from the light monitor that I showed earlier can shine down in the lobby. The shaded area is the art zone, where you have no overhead pipes that are no wet pipes can go over these. So you've got like a pre-action fire system. You've got pretty much everything has to all the pipes and overhead have to route through certain areas. And then level five interior finishes on the galleries. So BIM-wise, we did not receive any models from either our design build architect or the ODC who Randall Stout out in California. Therefore, you know, we weren't in with a holistic approach from the get-go. It's hard bid, so no subs really set aside money for BIM modeling. We kind of bought what we could get out of the subs and asked for participation. And we modeled the building. We modeled some of the underground too, just primarily to use for coordination. And I, along with Preston and Aaron and Adam Lloyd, actually assisted a good bit, modeled the building. And then we received the steel model, ductwork model, HVAC piping, and fire protection models from some of our subs. And now I guess I'll spin the model and show you what we got. So like I said, pretty challenging modeling the building. The geometries were difficult to do in Revit, but we got a lot of positive impact from modeling it that we didn't even realize we were going to get. Early on in the project, we've got really high ceilings, like I said, in the galleries. Because of that, we decided to go to bar joists rather than the structural steel beams that we were going to use. And through that, we could get a lot of this duct work. I don't know if you can see that very well. A lot of the duct work in and through the bar joists. Modeled the underground, very tight site, like I said, with footings and foundations going everywhere. We decided it was going to be worth it to model all the domestic water lines, all the storm drains, and we actually found a couple conflicts where the storm drain was running straight through a footing, and we're able to mitigate that really quickly. Another positive impact we got was just being able to pull up the steel model and show our steel erector what was going on. I mean, this canopy, the steel design changed from beams to bar joists or from beams to a truss system. You can see all that. That's difficult to see in 2D. That's difficult to understand. I don't care how long you've been erecting steel. That is those are difficult elements to understand how they're going in. And like I said, it wasn't just the wing canopy. There were stairs. There were lots of different parts of the project. So moving back, in addition to what we already had, I decided to model the plumbing. We had 2D drawings from the plumbing, converted that into a 3D model, and that actually helped us. And I'll get more on that in a little bit. Some lessons learned. Access doors. We had an interstitial space access door that we conduited over. We didn't get complete buy-in from the electrical subcontractor, and because of that, we make these mistakes in the field, and that costs money for somebody to fix. Where we now have to move all that conduit down the wall and over to get that access door in. So one of the biggest lessons learned we got to, when I modeled the plumbing, this was a couple months into the project, and after we had already erected steel, which is not the time that this needed to happen, but that's how it did. We came into a conflict with a steel beam in the lobby that the size had increased from a W21 to a W27, which killed 6 inches of our space, and the ceiling framing would have hit straight up into the end of the beam. And so because of that, we couldn't drill through the beam. There's literally no other routes because of the large floor opening. We had to go to the architect and start troubleshooting. And this is not the time you want to do that, but this is how it happened. And so you can kind of see this beam. You can see it on the model right through here, coming off the shear wall. No place to really take all this stuff other than drop the ceiling. And so we actually asked that the architect that the ceiling be dropped from 21 feet to 20 feet. Like I said, this was because of a steel size increase after the building had essentially already been coordinated. And we wanted to drop the ceiling to 20 feet. The problem was you've got 21-foot curtain wall that lined this room, and so we couldn't do that. The architect agreed to let us model it, use that model to determine when we slope the ceiling from the opening up to the 21 feet at the perimeter of the curtain wall. And here, I'll bring up that model and kind of talk through that a little bit more. So we modeled this separately and kind of figured out how far down the ceiling needed to start from to slope to 21 feet. And here's the curtain wall edge out here and out here. And here's that opening. This is a draft stop that the city made us put in for smoke. And so we remodeled all the HVAC lines, the fire pipeline, the conduits, everything, the plumbing lines that go through this area, that had to go through this pinch point, and essentially decided we needed to drop the ceiling, or we needed to start the slope at 20 feet. We could get everything as tight as possible, and you can see just how tight it is, over the ceiling and under the beam if we started the slope from the draft stop at 20 feet. And that's how it worked. And so, there's a problem that we kind of fixed on our own. And luckily, when we did this, we were able to mitigate some other problems too, with a sanitary line out here and an elevator enclosure through here. And so, like I said, not the best way in hindsight to have done it, but at least we found this problem. We found this problem before any of the pipe had been installed, saved a lot of money that way, and we're able to go to the architect, fix it before we had pipes sticking through the ceiling. So just some lessons learned from our project. All ceilings need to be reviewed and checked in the model. Make sure no pipes are under them. This sounds like an obvious one, but it's happened on numerous projects. Changes to the steel need to be incorporated immediately. Like I said, at the point when that steel was changed, the coordination effort was largely completed, and it was one that snuck past us. If necessary, hand calculate the clearances under the steel. We need to contract all the trade models up front. We got to have a holistic BIM approach if we're going to do it right. Like I said, we bought what we could on this project. Plumber only agreed to do 2D drawings. Electrical subcontractor didn't ever really get us a good model. Needs to be a holistic approach, because we could have mitigated some of the other problems that we had out there. just some more stuff. All access and roof access doors need to be modeled. You can place a structural column there as a place marker. MEP contractors need to indicate in their model where their access doors are going to be located. That's relentless pursuit of excellence, getting better. And then more stuff, shade pocket cans, projection screen cans, projectors, operable partition supports can be modeled. If we can model those, a lot of the times with specialty products like that, when you go and search the internet for their submittal data, their technical data, you can now find the actual Revit plugins to download where you can have these elements put right into your model. So now just switching gear to PLANGRID. Like I said, Trey's talked about PLANGRID for us before. PLANGRID, PLANGRID's helped us out a ton in battle time. I mean, just as a contract drawing, shop drawing viewing tool, I know that we've been looking at drawings on our iPad for a long time, but it's been an important one. We use it as a photo log for our project, for quality issues, for safety, for cleanup. I use it for 8M inspections, and I'll pull up PLANGRID in just a second. Like I said, here's where we placed photos quality-wise. Oh, sorry, it's upside down. It's not flipping.
Just a second. Let's see if we can.
There's photos. We can see updates on, taking pictures from the same spot. So like here's our light monitor. Here's some quality type photos that we took where we're showing interfaces between roof and wall. I can stack multiple pictures in one spot for progress. Sometimes our assistant superintendents take selfies and put them on there. But the best part about this to me is exporting the packet. And Trey Darnell showed me this, but from this we can, you have essentially an entire report with timestamp photos that are located, and a lot of this has gone into our quality book. So here to locate the photos, we've got captions on the photos, and then we can see exactly where the photos were taken, what time, what location it was taken in. So going back, that's really all I had, and I just wanted to communicate today how the BIM model has been effective on a smaller budget project with no BIM money allocated, and how PLANGRID has helped us. We take it for granted now, but it is a very inexpensive way to view and save time for us on our project.
Jordan,